Welcome back, everybody. This is the final of 4 parts in my lecture series on solving quadratic equations. If you haven't seen the first 3, go ahead and check those out first before watching this one. In this video, we're going to learn about the quadratic formula. Let's get started. The quadratic formula is probably something your high school teachers made you memorize over and over and over again. And I hate to be the bearer of bad news, but I am going to have you memorize it once more. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is an explicit solution to a general quadratic equation. When all of those other tricks fail, when I don't know how to factor, when I can't immediately use the square root property, when completing the square is going to lead to really nasty numbers like it did in the last problem of the previous video, I turn to the quadratic formula. Now, there is a mnemonic device that I learned to memorize the quadratic formula. And bear with me, it's a little bit of a stretch, but I think it's going to help you remember it. There was once a sad boy, and he couldn't make up his mind whether or not to go to the house party. But he decided to be square, and he missed out on 4 awesome chicks. Everybody got home at 2 a.m. Stupid. I'm aware it's stupid. Okay, cue the crickets. But it might help you remember it. So, this first problem, it would maybe be a little bit overkill to use the quadratic formula because I could factor this guy into x plus 6 times x plus 2 equal to 0. And then using my zero product property, I know x should be negative 6 or negative 2. But let's use the quadratic formula to verify this answer on a simple problem. X is equal to negative b, well, how about I just scroll up a little bit instead of spending a whole bunch of time rewriting it. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Just saying it again to really drive it home. In this problem, a, that's the, or circle, according to my tablet, a, that's the coefficient on the quadratic term, is 1. B, that's the coefficient on the linear term, is 8. And C, that's the constant term, is 12. So filling out this formula, I write x equals negative b, which is 8, plus or minus the square root of b, that's 8, squared, minus 4 times a, which is 1, times c, which is 12, all over 2 times a, which is 1. And now I just have a lot of order of operations to do from here. Cleaning up inside the radical, I get the square root of 64 minus 4 times 1 is 4. 4 times 12 is 48. And in the denominator, I'm left over with just 2. Let's keep it going. Now I have x equals negative 8 plus or minus the square root. 64 minus 48 is 16 over 2. That gives me negative 8 plus or minus 4 over 2. That's going to be, when I add 4, I will get negative 4 over 2. When I subtract 4, I will get negative 12 over 2. So x is negative 2 or negative 6. Sure enough, our answer checks out. Why don't you see if you can use the quadratic formula on this next one? Pause the video here and give it a shot. The answer that I found was x equals 1. Using the quadratic formula, I got x equals 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 1 all over 2 times 1. And you'll notice here that my square root term, by the way, the fancy name for this is the discriminant, is 0. So the plus or minus kind of doesn't matter anymore, and I just get one solution, x equals 1. I've got one last problem for you to try. Go ahead and pause the video here, see if you can do it on your own. The answer that I got was 1 plus or minus 4i. In this example, after we plug everything into our quadratic formula, remember a here is 1, b is negative 2, c is 17, you'll notice I get a negative number under the square root, this negative 64. We learned in the last series that to tackle that negative sign under the square root, I pull out an I, and then I'm left with 8. Fully simplifying that leaves me with x equals 1 plus or minus 4i. Thank you all for watching. That's going to wrap it up for this series. Catch y'all in the next one.